Picture this: 15 giant stars, dying one after another, exploding as supernovae within just a few million years. The combined shockwaves didn't just echo through space, they ripped it apart. Dust and gas were swept aside, leaving a vast cavity of hot plasma, still expanding today at 6 kilometers a second. Inside, temperatures soaring close to 1,000,000 degrees. And here's the twist: our solar system isn't heading toward it. We're already inside it. Welcome to the local hot bubble. This isn't some distant structure hiding far across the universe. It's our very own neighborhood, a scar left behind by exploding stars and a birthplace for new ones. But what exactly is this bubble? How did it form? And how did scientists even figure out we were living inside the aftermath of a cosmic chain reaction? Back in the 1970s, astronomers noticed a strange glow of soft X-rays scattered across the entire sky. They suspected maybe we were surrounded by a giant pocket of superheated gas. But the idea faced doubts. By the 1990s, some argued these X-rays might just come from solar wind colliding with atoms around us. So, was the bubble real or an illusion? The answer came decades later. In 2014, NASA's DXL mission confirmed it. Yes, the local hot bubble is real, a 1,000,000-degree pocket of plasma stretching hundreds of light years across. So, how did it begin? The story traces back around 14 million years, when a chain of roughly 15 massive stars exploded in close succession. Each blast pushed matter away. Each added heat to the void, and Earth carries the evidence. Deep in ocean sediments, scientists discovered iron-60, a radioactive isotope forged in supernovae. It doesn't occur naturally on Earth, which means the ashes of dying stars literally rain down on our planet. By measuring how iron-60 decays into cobalt-60 and then into nickel-60, researchers could even pinpoint when the material arrived. And the results matched perfectly with waves of nearby stellar explosions. Fast forward to today, astrophysicists like Catherine Zucker have mapped our region of space using data from ESA's Gaia telescope. The result? A 3D map showing that every young star within 500 light years lies along the outer walls of our bubble. The supernovae that once destroyed stars are now fueling the birth of countless new ones. You might wonder, if this bubble is filled with 1,000,000-degree plasma, why aren't we burning alive? The secret is density. The gas inside is so incredibly thin, hundreds of times thinner than normal interstellar space, that despite its scorching temperature, it cannot harm us. It's hot, but it's almost empty. Thanks to missions like Rosita, we now know our bubble isn't alone. Our galaxy is like Swiss cheese, riddled with cavities carved out by ancient supernovae. Some bubbles even connect through vast tunnels of hot gas, linking us to neighboring superbubbles like the Gum Nebula and Loop Y. And here's the most poetic part: our sun wasn't born inside this bubble. It drifted into it just 5 million years ago. Now, by chance, we sit right near its center, surrounded by the legacy of long-dead stars. So next time you look up at the night sky, remember, we are floating inside a colossal scar carved out by cosmic explosions. Some of the stars you see aren't just randomly scattered. They're clustered along the walls of a bubble blown open by giants that perished millions of years ago. The local hot bubble isn't just history. It's proof that death in the universe always leads to new beginnings. Stars may die, but their fire echoes on, shaping galaxies, birthing new suns, and reminding us how deeply connected everything truly is.